divide a concept into 3 levels of complexity. The first level is the computational level, which is the lowest and most simple level that we can think of. So that's, what does the system do? So for example, if we are going to think about an elevator, the description of what the system does is that it moves people vertically inside of a building to where they need to be from where they currently are. So that's just very simple. It doesn't go into any details about how fast the elevator moves, if it's an express elevator, if it operates differently at different times of the day. You could fold some of that in, but the computational level is very simple. It doesn't take into account any of the discrete inputs and outputs, such as like when the button is pressed, that signals to the elevator that it's going to activate the motor. So computational level is basically just defining what our design problem is, defining what our input and output basic delineation is going to be. And then next up is the algorithmic level. The algorithmic level is the next level of complexity, where we can then get into the more minute workings of a system. So continuing with the elevator metaphor. So computational is people move vertically inside of a building to get to where they need to go. The algorithmic level would be when a person approaches, they might see a illuminated sign that's going to tell them where the elevator currently is. There are buttons. When they press that button, it's going to signal an elevator that is going in the right direction, that it should make a stop at that floor. And then down the rabbit hole of all of the complexity we got into last week, where you're going to be working with a bunch of complex conditions and data about inputs such as the buttons outside of the elevator, the buttons inside of the elevator, any sensors that keep the doors from closing on you, any doors that keep, or any systems that keep the outside elevator doors, like the ones that are in the hallway, from opening unless the elevator is actually aligned with that floor, right? You don't want to have the doors open if the elevator's in a different position. So when we get into all of those little details of conditions, like if the elevator is here, then we can open the doors, then we're getting into the algorithmic level. And the implementation or physical level is where we are dealing with the actual implementation of the thing. So in terms of the elevator, it'd be like which motor you choose, the type of metal that you use for the counterweight, including all of the complexity of the previous 2 levels. And so this can be really helpful both when analyzing a system that already exists, such as the system by which we interact with an elevator or and even an escalator, or any system that you can think of that has some sort of interactivity. You can analyze similarly to what we did with the peanut butter and jelly sandwich. But not only is it useful for analyzing systems that already exist, this can be useful for creating systems that you want to exist. Say you are a developer working for some network-based, web-based application company. If they come to you with a project brief and you're the developer, they might come to you with the computational level of complexity, where they say like, oh, we need a system that allows users to interact with each other one-on-one or in groups in real time, where they can exchange encrypted messages or something like that. And then as the developer, it would be on you to extrapolate, and I mean, obviously through meetings and stuff, check in with your employer or client to then determine strategies and ways to deal with the actual data that you're using through the algorithmic level, where that's figuring out how you're manipulating that data between input from the user and output to the user, as well as then the implementation, which in terms of code might be what server you want to purchase some traffic from, or what kind of storage you need, or what kind of libraries or code repositories that you need to purchase in order to make this project actually feasible. So physical is kind of a misnomer when it comes to like this purely digital stuff, kind of, except for we need to remember that like all of these servers, they don't exist up in the cloud. The cloud is not up. The cloud is a server farm in like Montana or somewhere in the middle of nowhere. There's these giant buildings full of computers that are just on all the time. All right, 1 second. I think my dog needs to go out of this room. 1 second. Okay, go. All right. So, yes, moving on. So we're not going to do another exercise with that right now, but just keep that in mind that when we are working on projects, the first step is what do we want it to do, right? It's not, oh, I want it to be red, and then you move from there. Most likely, there are some scenarios in which that could be the case. But what we want to do is we want to first think about the function of what our project is going to do, and then we can work from there. All right. So now we're going to get into some of the stuff that we covered or that we briefly went into in last class. So we're going to start out with comparators, which you probably remember from, you might remember from math class. I'm not sure what all of your backgrounds are with that. But let me switch my camera over so I can write. I would be using the whiteboard, but I hurt my foot yesterday, so I'm going to be sitting as much as possible. So we'll be going with the paper version here. All right. So first thing that we want to talk about is comparators. So the one that we're used to is, I'll write them out first, how they're used in math, how they're written in most mathematics, and then we'll talk about how they're going to be written in our world. So there's equal to, greater than, less than, and then I'll put a couple over here, greater than or equal to. And less than, I'm just abbreviating LT and GT. And then one that not equal to. So that's just an equal sign with a cross through it, with it being crossed out. So basically, these are used to compare two different numbers. So oftentimes we'll use a variable. We haven't got into that yet, but we'll talk about that momentarily. So with those in mind, let's just look at some things here, some statements. So when we are using these, we're often going to be using them inside of our conditional statements, right? So we have if something, then do this, right? We have a condition that we are going to check whether it is true or false, right? So if something is true, then we're going to do this. If not, if it's not true, if it's false, then we will not do whatever is specified. And in our JavaScript world, that is formatted, where we have our if and our condition is inside of parentheses. And then there's a curly bracket, and after that, a closing curly bracket, and inside between these two curly brackets is the code that is going to be run if the condition is true. Also said, if the condition is satisfied, then we'll run this code. So going through some of these comparators, let's just say like if, we'll make a very boring one first. So if 2 is greater than 1, then we'll just say, well, let's see, I'll just put some pseudocode in here. We'll say thumbs dot up. 2 is greater than 1, yes. So we are using this sign to compare two values, right? Now we can replace this with any manner of numbers that we want using any of those comparators. So just really quick, let's just write out a few of those. So we'll start out, we'll do 2 is greater than 1, which we know is true. We have 2 is less than 1, which is false. We can do 2 is not equal to 3.14. That's true. And we can say 1.01 is greater than or equal to 1. That's true. Oh. And we'll just do 2 more. 1 is equal to 1. That's true. And I'll do one with a bigger, weirder number maybe. So let's see, 596 is less than or equal to 597. That's also true. Ooh. All right, so we can see that we have different ways in which we can compare two different values, right? Now I want to just quickly, instead of using these symbols, we're going to use some of the symbols where we're going to look at the symbols that we use in P5. So in a lot of code, not just P5. So in code, equal to looks like this: double equal sign or triple equal sign. And we'll get to the difference between these in a little bit, so don't worry too much about that at the moment. But basically, you can just know that triple equal sign is more stringent than this one. It's about data type, so we'll get to that once we've talked about data types. And I'll just put in parentheses, not the same as equal. A single equal sign is not used as a comparator. So we are not going to be using a single equal sign in the same way that we use double or triple equal signs in conditional statements. All right, greater than is the same, less than is the same, greater than or equal to, we just put them next to each other. Benny, do you have a question? Sorry, I just noticed your mic is unmuted. Okay, never mind. And less than or equal is once again just the less than and equal sign next to each other. And the last one, not equal to, is an exclamation point and an equal sign. So those, I believe, are all linked on the class notepad. I guess I didn't put a link to not equal to, but it should be right there on the same page. So when we write these, we're going to just replace the more familiar mathematical ones with this set of comparators. All right, so let's use these in some mock-up conditional statements. So we'll say first, if 3 is not equal to 4, then we'll say thumbs dot up again. So 3 is not equal to 4. This is true, and therefore we will run the code that's in between those two curly brackets, right? If 4.2 is less than 6.89, that's also true. So we'll say thumbs up again, thumbs that up. 4.2 is indeed less than 6.89, so we run the thumbs up code. And we'll play with all of this once we get into the actual P5.js editor. But the next thing I want to talk about is variables. So variables are stand-ins for numbers, right? They in mathematics, we use variables as symbols that stand in for numbers. Oh, just write all that. Symbols that stand in for numbers. So like just looking at some formula that you may be familiar with, or not even a formula, but like a line equation, right? So we have y equals 3x minus 9. Sorry if I'm giving anybody flashbacks, but this is basically, it's a rule, right? Our equation is a rule that is going to be able to manifest in different ways, right? As the value of x changes, so does the value of y. And you might have seen this written as this, right? And if you remember, this f stands for a function, which we might be familiar with from what we did in our last class, where we're talking about functions are action words. They're verbs. They're actions that we can take in code. And also, if we look at this, it looks like, oh, we have a function, and we're passing a parameter into that function. So this may be looking familiar to some of you, which means that basically this is our output. This is our input. And these other numbers, that's like our program, essentially. Our instructions for manipulating the input into the output. All right, so for this, we take a number, whatever that number is, we multiply it by 3 and we subtract 9, and then that gives us our output of this function. The difference with variables in code is they don't just have to stand in for numbers. They can stand in for various different types of information. And also, they're not just symbols necessarily. They can be any string of characters. So I can have a variable that might be pertinent for things that we were doing if you wanted to get into game design or graphic design. So you might have some variable called screen width. Notice I use this capital W here so I can differentiate between these words. So I might have a variable named screen width. I might have a variable named, let's see, user name. I probably wouldn't capitalize that N actually, but so it goes. So if we look at these, we can see that these are probably not both numbers. I don't know how many of you have friends with numbers for names, but it's generally less common than a name using letters or other text characters. So we can already see that these are different in some way. So this one uses numbers, and this one uses letters, right? And before I get any farther, I want to show how we let our code, let our programming language know that what we're talking about is going to be the name of a variable, right? We've talked about functions and methods and objects and attributes. Variables and objects are very similar in the way that you can kind of use them interchangeably when we're talking about them. But we need a way to tell our coding environment that what we're saying here is the name of a variable. So we'll say var. I guess maybe you should pronounce that var for variable, but I cannot stomach that personally. If you like to do that, go for it. But var screen width, var username, and this is called variable declaration. When we are declaring the existence of a variable, because we have to first tell the system, hey, I'm gonna use this as a stand-in for some sort of information before we can do that. We have to create it before we can use it. And now what I want to do is I want to put some data in so that these data types can make sense. So screen width equals 1000, and username equals Jesse. So just a couple things before we go on. You'll notice that there is a single equal sign here. Now, I said a single equal sign would not be used in comparison. This is used for variable value assignment. Single equal sign is for variable value assignment, where I got a little off screen, sorry. Where we're telling this variable that it is standing in for this value. So now I can see screen width has a value of 1000 held within it. Username has the text Jesse. And we'll note these quotation marks here. Those are important to let it know that what it's looking at is the text inside of here. Okay. So these are two examples of variables that have different data types, right? We were talking about how these are numbers and these are letters. So these are different data types. And it's important to keep data types in mind because the way that we utilize them is different, right? If I say like 1000 plus 29, like that equals, I'll just do a double equals just to make things less weird, maybe is 1029, right? But Jesse plus 3.9, what does that mean? I don't know what that would mean. So that, see, you can't use all of these different types of data interchangeably. So we need to keep track of what type of information we're using. And so here I say numbers and letters, but more specifically, what we do is we would call this not numbers, but an integer. And integers are numbers, are they're whole numbers, basically. That's like any negative number, any zero, any positive number, anything that is doesn't have a decimal point. And letters, this is going to be called a string. So a string is where we have a series of characters. And there's different things that we can do with each of these. So there's a lot more data types. We'll look into those in a bit. But let me just check my notes 1 second. Yeah, okay. So what I would like you to do now, if you have already signed up for your p5js.org editor account, please navigate there. If you haven't, also navigate there and make sure to sign up. All right. So once you're signed in, you should see basically when you go to a new sketch, you'll see this. And so what we have here is we have two function declarations. We're saying that we have a setup function and a draw function. And these are functions that come along with P5. And so now this bears explaining what exactly P5 is. P5 is a library that extends the functionality of JavaScript. So JavaScript is a client-side programming language, client-side in opposition to server-side, and that means that it's running. The code is running on your computer in your browser. It's not necessarily receiving data from elsewhere once the code is loaded into your browser. A library is another JavaScript file in this case, or whatever programming language you're using. It is a bunch of code that adds further functionality to that programming language. So P5 specifically was made for visual work, for artists to be able to create visual and graphical stuff using a little bit easier to read language than is natively in JavaScript. So the setup and draw functions, these are part of the P5 library. And the way that these work is the setup function runs one time at the when you load the code. I'll say when you load the page. So the setup function will run first, only one time. And the draw function runs over and over and over until you close the page. And what I should do now is I should explain what it is I'm doing here. So I'll make another line here and I'll say text preceded by 2 forward slashes is a comment and isn't run as code. So the 2 slashes is telling the browser, this part right here is not code. Don't worry about that. That's a note to the programmer. So these, if you are writing code, comments are really good to use because they allow you to organize your code with references so that if you're going back to look at what you've written previously, you can have some information about what you were trying to do in the section, or if you're working with collaborators, it can be very helpful to say like, oh, in this section, I'm dealing with the encryption, or this variable is tied to whatever this information source is. So comments are important and use them. Especially, please use them when you're working on projects for this class so that you can submit code that I don't have to necessarily do a full archaeology through. I can see your comments, and if there's any point at which you're having trouble with your code, if you make a comment in that area that says, I'm having trouble with this section. Also, one thing to keep in mind, especially when we're working collaboratively or with someone who's here to help you, see these numbers right here. These are very helpful. The numbers to the left are line numbers, and you can use them to identify sections of code. This is line 3. So you see how when my text like wrapped over to another line, we don't have a new line there. It's just every line break, every like return character is going to make a new line number. So if I'm having trouble, I could say like, oh, I'm not sure what's happening on lines 8 through 11. Can you help me with that? All right. Oof. All right, let's see where to go from there. Okay, so I mentioned that the setup and draw functions are part of the P5 architecture. So before we go any farther, let us look at where that P5 architecture is. So if we go here, this little arrow right here to the left of the name of our sketch file. I guess I should back up. This is the current name of our sketch file, the file name. And that's the default name for a P5 sketch. They call a program that you've written in P5 a sketch. So this right here is going to expand to show us our file structure for the current project that we're working on. And if you're used to a code editor, Sublime, brackets, whatever, this is probably familiar. But just in case you're not, remember that because this is something that lives in the browser, we're going to be dealing with HTML, right? And most likely CSS. So our P5 sketch is not a standalone JavaScript file, like it's not just this JS file. It's also the HTML file that holds that JavaScript file. And if you look here in this HTML document, this very simple HTML document for this very empty project, we have inside of the body tag, we have this script tag. And the source attribute is pointing us to sketch.js, which is right here, right in the same folder as our project. And if you're working in brackets, you're going to have all of these files in the same folder most likely as well. And now I want to look inside of the head tag right here. These two script tags here, these are, well, more specifically, this first one, this is the JavaScript file that holds the P5 library. It holds all of the JavaScript code that defines all of the functions and variables that come along with P5. So this, we need to make sure that this is referenced. And the way that we do that is we have this script tag inside of the head tag, between the opening and closing head tags in our index.html file. And this one here is a further library for P5. This one allows for using sound, where it can access the speakers and microphone in your computer if you allow it to do so. All right, so just moving on, we're going to do some more fun stuff with this. Next thing, we want to make sure we always do, same as with any digital practice, we want to make sure to save our work. If you see this URL right here, it's not anything unique, and that means that one, I'm either not logged in, or two, that I'm not saved. And this dot next to this file tells me that I have unsaved changes. So I'm just going to go to File, Save, or Command S or Control S. And now I'll save it. And it's saved. And now you see I have this unique URL with a bit of mishmash of characters there that's going to be unique to my sketch. Well, along with this part here, but this is the generated thing that's going to be the address of this sketch. Here, Onyx Tower, it generates random names for your projects as you start with them. So I'll say MMP 210, MMP 210 demo 1. I shall say week 2. There we go. So now we have a super basic saved P5 sketch. And just for fun, let's run the code. We haven't added any code to this yet. We've just added comments. But if we press this play button here, over here, it's going to run our code and create a square that's 400 pixels wide and 400 pixels tall and has a background color. So let's look at how that happens. So first thing, we have this create canvas function, and this creates a HTML5 canvas that will display our code. And so this is creating an element in the HTML file, in the HTML document as it's being run by the browser. So this is our work area. This is where we can make stuff happen using P5. In this case, it's 400 pixels by 400 pixels. So the create canvas function here, we're passing two arguments in, or we're using two parameters, the width and the height. There are scenarios in which you can add more parameters. If you're working with like a 3D space, there might be more stuff going on, but we're going to stick with two-dimensional canvas for now. And so now here, I'm just going to move this up so it's a little bit. All right. And so now in our draw function, which once again runs over and over and over, this is where we're actually going to do the dynamic part of our code. Because it happens over and over again, if anything changes as far as inputs into the system go, then that's where we can make things change for outputs. But first, let's look at the background function. So background will fill the canvas with a specified color. In this case, we're only specifying one value, which means that we are going to be specifying a grayscale color. And this is a good time to look at the P5 documentation. Let's say I forget what background does, and I want to know how do I use this? What do I do with this? What we're going to do is we're going to go to p5js.org and go to the reference section. And this has pretty much all of the tools that are available to you in P5. There are some things that aren't in here because there are parts of JavaScript that are not listed here. Because P5, as I mentioned, is an extension of the JavaScript programming language. So all the stuff that you can do in JavaScript, you can do in P5. And then there's some stuff in P5 that is not available in vanilla JavaScript, in just base generic JavaScript. But so this has a list of a bunch of different functions and variables and events and all of this. So if I want to know what something does that I'm seeing in a piece of code, I can just use my handy find in page, Command F or Control F, and I can just type the function or whatever I'm looking for into here, and then it'll bring me right to it. So I can click that. And here we go. Here's my reference for background. So yes, this function is going to, yeah, you can read through this later. I'll just add a link to this into here as well. And so here, I'll just go with the first two examples. We can change it to a different grayscale value, grayscale meaning anywhere between white and black, or we can specify red, green, and blue color channels to have any of those channels throughout our whatever 16-bit colors or 8-bit color system. So our values can go up to 255 in here. So let's just play around with that a little bit. So if I'm running this code, right now I'm at a gray that's mostly there towards white. If I go modify this to 255 and run my code again, now I have a white background. If I change this to 0, I have a black background. If I go right in the middle, 127, oops. Now I have a medium gray value. Now I can add in other colors. So if I want yellow, it'll be red and green on with no blue. And let's say I want like an orange color, then I might do something like more red, less green. Get orange. I can add a little bit of blue in if I want to mute that down. That's a nice salmon color. So, okay, so I can change this background color. And what this is also leading us into is, remember we were talking about how code happens in order. It goes from line 1, line 2, line 3 down until we get to the bottom. And then, well, then it's going to be limited into the part that's repeating. So we'll, in this example, we're going to go, oh, I see something is happening in the chat. 1 second. Ah, great question, Emmanuel. So in HTML, don't we use codes that represent colors in hexadecimal? So the question there is, here, let me see here. So like red is the example is FF0000. So remember that this is a hexadecimal color code, right? So we can break these into our red, green, and blue channels, right? So this example for red, this directly corresponds to 255, 0, and 0, right? Because our hexadecimal code is going to count up from 0, 0 to FF. Maybe this makes sense for me to switch my camera around. 1 second. All right. So, all right. So first of all, let's look at the range of 0 through 255. Right. So this means that there are 256 options. Right. We have 1 through 255 and then 0. So 256 options in there. So this number is important because we might recognize this number. It's a power of 2, right? So we have 2 to the first is 2, 2 to the second is 4, and so on. 2 to the third, 8, 16 is 2 to the fifth, or sorry, 2 to the third, 2 to the fourth, 2 to the fifth is 32, to the sixth is 64, to the seventh is 128, and to the eighth is 256. So this is important because this takes us back to binary, right? So that means that in a number that is 8 binary digits long, we can represent any number between 0 and 255. So 0, 0, 0, 0, 0, 0, 0, 0 equals 0 in binary over here and decimal over here. 0, 0, 0, 0, 0, 0, 0, 1 is 1. Is 2. And we're going to go through all of them up to 256. No, we're not. That would be madness. But then we'll skip a few. So by representing our numbers in ones or zeros, we can get, if we have 8 binary digits, we can get anywhere from 0 to 255. However, this FF situation is in something called hexadecimal. Oh. Yeah. And so this is base 2, like by is 2. This is base 10, des for 10. This is base 16. Hex 6, des 10, 10 plus 6, 16. So in hexadecimal, to represent an 8-bit number, we don't need 8 digits. And we don't need 3 digits kind of for decimal. We don't use all of that. But we're going to have 6 digits. So 6 digits in hexadecimal can represent 8 digits, or sorry, that I said that wrong because I got ahead of myself. Hexadecimal just needs 2 digits to represent an 8-bit number. We have 0, 0. This one will be 0, 1, 0, 2, 0, 3. Oh. And then eventually, let's see, I want to actually, eventually as we get to 255, we'll get to F. I skipped some of the most important part here because I ran out of room, I realized, but these are equivalent numerically, they're just talking in different bases. So just before we move too far along, the hexadecimal digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, F. So if we were counting in hexadecimal, we have just that 0, 1, 2, 3 through 9. We have all of this. And then the next number after this would be 10. Then through 19. And then we'd have 1A, 1B, 1C, 1D, 1E, 1F, 20. So we're just adding those A through F at the end of 1 through 9, and then we're counting through in the same way. So yes, in HTML, we use hexadecimal, which has this range of 0, 0 through FF for each channel. So we have red, green, and blue for 0, 0 through FF here, 0, 0 through FF here, 0, 0 through FF for each channel. And then those get jammed together into something like what you saw where we have the hashtag in common usage there, FF0000 for red. You can, let me share my screen again. You can do that in P5 as well. But it's not necessarily the most helpful when we're thinking about colors, just because, like, I mean, it takes a bit of time to internalize the hexadecimal color naming system, because, I mean, it takes a while to break out of the standard decimal base 10 world that we are all trained in. So I hope that didn't get too rambly. There's a lot to get into here. I hope that answered your question well enough. So you can use hexadecimal, but that's just a different numerical base. All right, so let's see here. So what we're going to do, I need to get rid of that. We're going to define a variable, or we're going to declare a variable. So we're going to say var my first variable. I've made a variable. It exists. And so this is declaring a variable named my first variable. But right now, this variable does not have any value attached to it, right? We don't have equals 9 or equals hello. We don't have anything of that sort yet. So this variable right now does not have a data type. So I'll share this this sketch Oh, strange. So yeah, I'll share this sketch with us in the class notepad so you can look over this. But so now what we're going to do is we're going to do what's called variable. We're going to initialize this variable. So I'll do that inside of the setup function actually. Initializing a variable is done by assigning a value to it. So now I'll say my first variable equals 3. So now we've initialized this variable, and now it has a data type. Now this variable and that is, it's an integer. It's a whole number with no decimal point. There's other data types, which it doesn't look like we are probably going to be able to get into much of today, but I'll put some links in the class notepad for you to look at as well. All right, so we have this variable. Now what we're going to do is we're going to use it. So let's make no, we'll just leave it as is. Okay, so here in our draw function, we're going to make a new line of code, and we're going to make our first conditional statement. So I'll say if my first variable, and capitalization matters, right? If I did this, that is not going to be happy with us. So, or it shouldn't be, it might be, but avoid capitals, avoid recklessly using capitals. Let me say it that way. So if my first variable equals 3, and so right now, my first variable does equal 3. So this condition is going to be true. So what we're going to do is we're going to do something new. We're going to use what's called the console. And the console in the P5 editor is right here, or there's an instance of the console. So we'll use that first. We'll say console.log true. And so I'll just make some comments. This condition checks if equal to 3. And this will print out whatever we specify in these parentheses into the console. So now if I save and run this, now we not only are getting our color background, but we're also repeatedly printing something into the console here. We're just yelling true over and over and over again at this point, because this is not a very exciting program yet. Now we can have an else statement. And so else doesn't require a condition, because if we remember, else is kind of like the catch-all. If this is not true, if this conditional statement is not satisfied, then we'll move on to the else. So I'll say console.log false. And I'm going to put some, oh, I need to put quotes around that. My bad. I'll put some exclamation points and a frowny face there. All right. And so also remember, end every line of code with some functionality going on in it in a semicolon. There are some instances of lines of code where like you have an else where there's an open curly bracket that you don't need the semicolon on, but just remember, have a habit of putting those semicolons in. All right. So now if we run this, I'll save it, I'll run it. Nothing is going to change in functionality. But if I change the value of my first variable, of the variable name, my first variable, to something like 4, false. You see, so now we have a different thing coming out of the console. And granted, this console is not super exciting, but it's extremely important because it is going to let you check your code. It's going to, you can, if something is not working the way it should be, you can say like, oh, I think that at this point, this variable should have this value. So you can add this console log in there and it'll populate information in. Also, if you've made a mistake like this, right? I haven't put any number in there. I haven't put anything into assign value to this variable. When I run my code, if we look here in our console, it's telling us that there is an error in our code, and it also is very friendly and tells us what line it ran into the problem in. And let's see, one more thing with the console. If you're on a different page, if you have a project that you've hosted on GitHub or on your own server, you can access the console still. If you right-click or secondary click in Chrome or in other browsers and go to Inspect or Open Console, you go here and you go to the console, we can see that we have our console here. There's nothing really happening in this Wikipedia page, but if we have the console, we can open it in other pages and we can use that to debug our code. This is not the most exciting situation here, but that's okay. We'll get to more exciting stuff very soon once we start dealing with more complex user interactions and events.